Hello, welcome back to the Play My Tutorial channel. If you have watched any of the most recent videos, then you will know that I was planning on creating a calculus playlist, but the videos, I lost those videos, so I'm redoing the playlist. So let's get into this video.
Took a swing at a wrecking ball and I prayed for my downfall.
Calculus was established by two individuals in the later part of the 17th century. Even though there are other contributors to calculus, these two individuals were the ones that established it. And these two individuals are Isaac Newton and Gottfried Leibniz. So these two guys created calculus, which is just an extension of mathematics. I know at times calculus can be tricky, but just consider it as an extension of math, and it just has three topics. And the three topics are limits, differentiation, and integration. Under these topics, we have subtopics that we will look on. So let's start off with limits. To me, limits is the most important topic in calculus as it is the topic that combines or connects all three topics. Limit by definition is just the analysis of a function at a particular point. So the limit, when you look in a book, the limit will be written like this. Limit of a function f of x as x approaches a point a. You read it as the limit of a function, whatever function it is, as x or whatever variable approaches a point. Let me do that graphically to show you what I'm talking. Let me use an example, exponentially shaped graph. Something like 1 over x would shape something like this. So my function, let me do that in blue. My function, f of x, would be equal to 1 over x. I know this isn't drawn perfectly, but 1 over x is somewhat shaped like this. So a point, any given point, say this is my a, because your a will always be on your x-axis. The corresponding point to a on the function would be right here. So as my function approaches a, never reaches a. So that's why we say approaches, or in some books or some teachers would say tends to a. So as x approaches a, and it can approach a from either side. So you may see this in a book, the limit of the function f of x as x approaches a. If you see a minus in the superscript section, then it is approaching from the left. If you see f of x as x approaches a with a plus there, this is a plus, then it is approaching from the right. Let me do this better. Now this function, as x approaches a, the function tends or approaches a point as well. So I'm approaching from the left. A is a value here, so I'm starting from 0 and going up to a, whatever value a is. So as I go up towards a, then my graph comes closer and closer to the 0 and the y-axis. And if I approach it from the right, the same thing happens. So if I'm approaching from the right, the same point it will correspond to on the y-axis. So your limit will be whatever value is here. I was just interrupted, so let me go back to what I was saying. I was saying that as you approach a from the left or from the right, the corresponding point here has a next corresponding point on the y-axis. So as x approaches a, never at a, but as it approaches a, the function approaches 0. Say this was 1 here, and my a was 1 also. At 0, the y-axis is an asymptote, the vertical asymptote. This is 1 actually. We can see that at this point, whatever point is here, whatever point is right here, we can see that the function is further away from 0. And as we get closer and closer to our value a, say we are here now, then this is where the function is. So we can see that the function is getting closer and closer to 0. This video is not about limits, so I will just leave it here because I need this video to be really short. So that's limits. Now on to the next topic, differentiation. So if you are a calculus student or you're just starting calculus, this is differentiation. So you will see this notation d dx or whatever variable. This is just telling what you're differentiating with respect to. So d dx. You can also see dy dx, but the y is just the function. So remember when you did functions and relation back in high school, your teacher probably told you that f of x is the same thing as y, or you can replace f of x with y, and this is just when y is the independent variable and x is the dependent variable. So you're saying you're differentiating the function y with respect to x. So say your y was equal to 3x squared plus 4x plus 3. When you differentiate this, you can differentiate this by saying dy dx. This is a notation, and I'm not showing you how to differentiate in this video. It's just an introduction to calculus. So if I differentiate this, I would have 6x plus 4, and the 3 would become a 0. I can also write this notation as y prime, meaning I differentiated it once, and I can also write it as f of x prime. And why am I writing sideways? Let me try and straighten these two. All three notations are saying the same thing. So you may see y prime or f of x prime or dy dx. These are saying the same thing. So that's differentiation. But let me show you a thing to tie all this up, because what I did now was just an example. And in calculus, differentiation is technically finding the gradient of a curve or a slope, or just finding a gradient technically. When you were in high school, you were finding gradients of straight lines. So this is my function f of x, and this function is x, right? So y equal x. Let me write that y as y equal x instead of f of x equal x. So y equal x. That's my function. And we know that y equal x is a mirror line, meaning that what is on this side is on this side, because it's a mirror line. Remember when you did things like reflection back in high school, where you draw your y equal x line, you can do a reflection on the other side of the line, because this line, along this line, is symmetric on both sides. So on this side is 45, so on this side is 45. So if I have my point here and my point here is 1, then if I go straight up to the function, the corresponding y value for this would also be 1, because it's symmetric. If I'm supposed to choose a next random point, say I choose 0.5. This is 0.5, this would be 0.5 as well. Now, let me label my axis. Now, when you found the gradient back in high school, the gradient m would be equal to rise over run, or some would say change in y over change in x. In this case, my change in y would be 1 minus 0.5, and my change in x, sorry, this would be x. My change in x would be 1 minus 0.5, which would leave me with 0.5 over 0.5, which would be equal to 1. So the gradient of this slope would be 1. And if I differentiate x, if I am given x to differentiate, I'll get 1. And you will see that later on. So if I have 1, sorry, not 1, 1 is a constant. So when differentiating in the future, remember that derivative of x is equal to 1. So when you differentiate, your answer is the derivative of the function. So I'm just saying that to let you know. I noticed I never said it earlier. So when you find your answer, that's your derivative. So if I differentiate, if my function is y, and y is equal to x, then if I have dy dx, my answer would be 1. And I hope that this is clear as crystal, because, well, even if it's not clear, when I'm doing the differentiation video, I hope that it will be better for you guys to see what I'm going at. So now to the last topic in calculus, integration. So just now when we looked at differentiation, we saw the notation. And by the way, integration is the opposite of differentiation. So if you know the derivative of a function, let me just do this. They are the opposite of each other. So this is the notation, and it's the integral sign. Let me do that a little better. So that's your integral sign. Inside their integral sign, you'll have your function, whatever function it is. I have x because it's a function of x. It doesn't have to be a function of x. And then here you would have dx, the variable that I'm differentiating, the variable that I am integrating with respect to. So I'm integrating with respect to x. So I have dx. If I had theta here, I'd have d theta. So this is integration. And if you see an integration question like this, no number here or here, then you say that is indefinite integration, right? Indefinite integral. You're finding the indefinite integral of the function. So what I was saying earlier, where I was stuttering, this function here, if I integrate the function here, whatever function I get, and you normally use a capital F when you integrate. So whatever function I get when I integrate, then this function would be the derivative of this function. Highlight it again and say what I was saying. If I integrate 5x to the 4th power plus 3, and I'm integrating with respect to x, then I would have 5x to the 5th over 5. I didn't have to write the 5 back, but I'm writing this for teaching sake. So over 5 plus 3x over 1 plus c. This is my integral. And let me write this better. So this here is the integral of this function. If I integrated f of x, I get the integral. And if I differentiate the integral, I will get back my function. So now, if I differentiate this, I will be getting back this. So let me differentiate it in this little box here. So remember that this would be just be this, x to the 5th, right? Plus 3x plus c. C is just a constant, and I know I have not gone through differentiation yet, but I'm just doing this to show that you will get back your function here. So when I differentiate x to the 5th power, I'd have 5. I'd have 5. This is not writing properly. I would have 5x to the 4th power plus 3, and this would be 0 because it's just a constant. And that would be my derivative of this function. Now you can see that integration is just the opposite of differentiation. That's what I'm trying to say. So this here is what we call indefinite integration. Now definite integration, you'd have what we call limit of integration. And I will show you these graphically as well. So the limit of integration, so you'd have actual values here. So my a and b would be limits. So if I have a function, now without limits, if I'm supposed to find the integral of this function, x, without any limit of integration, I'm supposed to find the area under the curve. So to whatever limit this goes to, I'm supposed to find the area under the curve. So integration is just finding the area. When I'm doing the integration video, I will go deeper in explaining. Now, if I add limits, my limits would be boundaries. So I have a function, and I just want to find the area under just one section of the function. So without limits, I was going to find area under the entire function to whatever extent. So now I have limits. So A is here and B is here. These are my limits of integration. Now I will not find the area under the entire curve. I will just find the area between these limits. So I will find the area inside that section there. And that's integration. That's the last topic. So if I integrate x, I'd have x squared. And this is without limits. So now say I change my limits. I have 1 and 4 for my limits. After I integrate, I'd have to evaluate. So x, and I'm evaluating between 1 and 4. So I subtract my upper limit from my lower limit. I'd have my upper limit first. So I'd have 4 squared minus 1 squared, which would be 15. So the area under the curve between 1 and 4 of x would be 15, and 15 units squared, whatever units it is. Unit should be squared when you're finding area. So I know this video was longer than expected. I wanted it to be as short as possible, but I wanted to go through all the 3 topics. So that's it for this video, guys. In the next video, I will be looking at an introduction to limits, and I will be going through limits, then going through differentiation, and then onto integration, and then I will close the playlist. And I will do other calculus videos, but they won't be in a playlist, or I'm not sure yet. I'm just doing as I go along. So thank you guys for watching. Please subscribe if you're not a subscriber, and the next video is on its way.
Took a swing at a wrecking ball and I prayed for my downfall.